Okay. This is the test corrections for Chapter 5-6 test. These were sections 5-1 to 5-6 and 6-1 to 6-2. This was taken December 11, 2015. Again, directions always the same. Show all your work in the space provided and box your answers. Triangle has vertices A, -3, -1, B, -6, -5, C, -1, -4. Which transformation will produce an image with the vertices A prime 3, -1, B prime 6, -5, and C 1, -4. So if you look at both the coordinates for, let's just look at A, -3, -1, and 3, -1, you'll notice that they have the same number, but the only thing that's different is the positive and negative values, right? Notice how the y values don't change and the x values do. Okay, so I don't really need to actually look at all of these, so I'm just going to create a rule. So if I graph -3, -1, left 3, down 1, and then I graph 3, -1, that would be right 3, down -1. So if I look between these 2 points here, I know that it's kind of folded over on this line here, which is called the what? The y-axis, and that is the answer. Okay. Now, here is a longer strategy. You'll get the answer right. Is basically doing each of these transformations to the problem, and you'll recognize if you reflect it over the x-axis, it doesn't work. Okay. -3, -1. If you reflect it over the x-axis, remember that would just be counting towards the x-axis and counting past it. That will give you the coordinates -3, +1, which is not the answer there. Okay. Question number 2. Which of the following transformations creates a figure that is similar but not congruent to the original figure? So this is the big idea between chapters 4, 5, and 6. In chapter 5 and 6, we're talking about how all the triangles are exactly the same. But they want a transformation that creates a figure that is similar, not congruent. So similar meaning one small and one big. Well, a translation can just move a figure. A rotation turns it. The answer is C, because a dilation actually creates it, right? We just saw that in the last chapter test in chapter 4, and that problem on the backside. It's just making your problem triangle dilated or bigger, enlargement. Okay. Question 3 and 4. Use quadrilateral MNOP to answer questions 3 and 4. Question number 3 says, name the coordinates of O prime after a clockwise rotation of 207 degrees about the origin. So first thing I'm going to do is I'm going to find the coordinates for O. Here's the origin. So that would be right 4, down 2. 4, -2 is my coordinates for O. I need a clockwise rotation of 207 degrees. I taught you guys this trick. Basically, it works for every 90 degrees. You change your sign of x. So this is positive, becomes negative. So think of this as -4. And now they switch places. Now you've rotated it 90 degrees. So this trick works for every 90 degrees, which means you have to do the trick 3 times. So we've done it once. Change the sign of x. That becomes negative to positive, and then switch these places. Do it again. Change the sign of x. And switch places. And you get the answer to be 2, 4. I gave you 2 points for each correct blank. So having a difference between negative and positive is important here. Question number 4. Name the coordinates for n prime after a counter clockwise rotation of 180 degrees about the origin. So the key word here is counter. I gave you guys this equation, if you want to write that down on your formula sheet. Clockwise plus counterclockwise equals 360 degrees. So if they give me counterclockwise to be 180 degrees, right here, well, I need something to add to be 360. That's 180 degrees, which means I'm going to have to apply the trick twice. They want n prime, so I get the coordinates for n. Here's my origin, so I'm going to go right 1, down -1. 1, -1. Change the sign of x. It's a +1, now it becomes -1, and then you just switch the places here. Change the sign of x. That comes negative, now it becomes what, class? Positive, and this one is, you switch the y to the x, so now your coordinates are -1, 1. Remember, I'll be posting these on YouTube, so if you ever want to watch it again or we went too fast in class, you can watch it again. Question number 5. What are the coordinates of each vertex if the figure is translated 3 units to the right and 2 units up? Okay, so here's a great thing about multiple choice. You know the answer's there. And if you know the answer's there, I only have to really do one problem. I'm only going to pick one of these problems, one of the vertices to do. I only picked B. I just so happened to just pick one of them. To get that coordinate, right 2, up 5. And when it says translated 3 units to the right, that means plus 3 on the x coordinates. And up 2 units is positive 2 on the y, so I'm looking for 5, 7 for B prime. And notice how that's the only one. Okay? D is your correct answer. If you really wanted to, you can do that for all of them, but really all you're looking for is just I only needed one. Now, I created a rule here. You could have just actually used a visual, right? You could have taken your coordinate, you could have counted 3 units to the right, and then 2 units up, and you would have gotten 5, 7 as well. Question number 6. Which triangles are congruent by ASA? Okay, so I need 2 of the 3 triangles. Now, if you look at this here, this one is side, side, angle. Okay, notice how again you have to go in kind of an order from start to finish, and I can't use that triangle. Now, if I look at this triangle here, this one has 4 congruent marks. Okay, so which means that I can use side, angle, side. I can use angle, side, angle. And if I don't look at this mark here, I can do, this one here, I can do angle, angle, side. Same thing over here, side, angle, side, angle, and angle, angle, side. So both of these have ASA. It would be these 2 triangles. Question number 7. What is the value of x? Again, here they have 21 here. They both have 21, which means it's what type of a triangle class? You have an isosceles triangle, right? Because you know 2 sides are congruent. This is called the base angles theorem. It says if the 2 sides are congruent, then their base angles going across, that's why I drew the arrows, these are also congruent. So draw congruent marks. If you look at this problem, what is the value of x? X is a degrees. So I know the student, when you know it's talking about degrees in a triangle, well, you know that the degrees in a triangle are equal to 180. This is a type of problem where you wouldn't use something like Pythagorean theorem. Pythagorean theorem solves for sides. So if I know this is x, they are congruent, so you can put an x here. Then you can use triangle sum theorem. X plus 38 equals 180. Combine like terms. Subtract 38. Divide by 2, and you get x equals 71. That side was 18 points. Back side. Directions for 8 and 9. Use the figure below and complete the congruency statement. If there is no congruency, write none in both. So for question number 8, I have a missing or a hidden. Class, what is that? Reflexive, so you put your 2 marks there. So maybe that's something you add to your formula sheet. You write down all your hiddens, just as a reminder for yourself. That says SAS, SAS. There it is. So that was 2 points per blank. 2 or nothing. Notice the direction that they've given me says A, B, D. So notice the marks we go through. 1 hash mark, 1 arc, 2 hash marks. 1, 1, 2. It has to be C, B, D in that order. Question number 9. Class, what is my hidden here? Vertical angles. So I have my congruent marks there. Now I just go in this order. Angle, angle, side, or side, angle, angle. Okay, remember it works for both, right? It has to work for both. Angle, angle, side, or side, angle, angle. Now, To get this, remember, you have to just go through and look at the congruent marks you're going through. So QRT, Q has one arc, nothing towards 2. So that would be 1, nothing, 2. That would be PST. Question number 10, I gave 2 points for each blank. Name the congruent triangles and their congruent parts. Can I get you in there? Yeah. Triangle FGH. So you start here at this F, you're going towards the right angle, and then 2 arcs. That would have to be FEI, starting at F, going through the right angle, and then 2 arcs. Angle EFI. So starting at the right angle towards 1 and then 2 arcs, same thing. On this side it would have to start at the right angle towards 1 arc and then 2. Angle G is the right angle that corresponds to angle E. And remember, you can use the picture, which can be confusing, or you can just use the congruency statement. H is the 3rd letter, I is the 3rd letter. So this is how important just getting this statement is, then you can use it correctly, right? FG, 1st and 2nd letter, FE, 1st and 2nd letter. GH, 2nd and 3rd, EI, 2nd and 3rd. FH, 1st and 3rd, that means 1st and 3rd, FI. Question number 11. For each pair of triangles, tell which postulate makes the triangles congruent. If there's not enough information, write not possible. So you have a square here, or I guess we can call it a rhombus because we don't know the sides are, all the angles are right angles. You have your reflexive, so you do side, side, side. Question number 12, using the given postulate, tell which parts of the pair of triangles should be shown congruent, which means you need to add a part, right? It says tell which parts. So I have the angles already marked. That means I need the included side in there. So AC to EF or CA to FE. Question number 13, I don't like cats nor dogs, so that would be neither. Question number 13, tell which of these triangles is HL. Here I have angle, reflexive side, angle. This one is side, angle, side. The only one that has HL is here. This would be a side, then they share this side, reflexive, and then angle. Angle, side, side with the right triangle is HL. Question number 14 with the proof. GH is to bisect EGF. So this is the angle up here. It's cutting in half this angle up here. So there's your congruent marks. EG is congruent to FG. And then you have reflexive. So this would have been side, angle, side. Notice here, I'm writing each of these as a one statement, one reason for the givens. If you got the givens right, I give you 1 point. Here, a lot of students got confused about which angle is being bisected. This is not a perpendicular bisector. It tells you up here EGF, so the knife is cutting in half this angle up here, so I need these angles. So angle G would not be specific enough. Angle EGH and FGH. You have your reflexive, GH is equal to GH. And if you look at your picture, that would be SAS, SAS. Remember, once you prove the two triangles congruent, you can say that their parts are congruent, which is either sides or angles. And that would be CPC, TC. This side, if you got 3 of them correct, 3 checks, I gave you 3 points. If you got 2 of them correct, 2 points. A correct meant like it had to be a statement and a reason. That would be 1 check, right? You have to be both correct to be 1 check. And 1 point if you tried. That side was worth 32 points, and the test was out of 50.